section 7.2, two variable linear systems. So we're going to look now at the method I prefer to use, but it's really the best to use if you have two variable or three variable or four, but the system is of linear equations. So if there are any quadratics, cubics, square roots, whatever, you're probably better off using substitution. But if all your equations are linear, then the method of elimination, I think, is far preferable to the method of substitution. So you want to get coefficients for x or y that differ only in sign in all the equations. So you want opposite coefficients, okay? So if x, for example, has a coefficient of 2 in one equation, you want a negative 2 in the other equation. If it has negative 7/3 in one equation, you want a coefficient of positive 1/7 in the other equation. So how this works, you want opposite coefficients. So you look 2 and 5, negative 4 and 1. So you don't have any to start with. You have to obtain them by scaling or multiplying one or both equations by the same number or different numbers. Now 2 and 5, to get a least common multiple, you'd have to multiply the first equation by 5 to make this a 10. Then have to multiply the second equation by 2, or negative 2, to make this negative 10. So you'd have to multiply both equations by different numbers. Negative 4 and positive 1, you'd only have to multiply the second equation by 4. The first equation you could leave alone, and you wouldn't have to scale it at all. So I'm going to take the second equation and multiply everything by 4. So you're going to have to distribute that 4 into the whole equation, to the 5, to the 1, to the negative 1. So let's rewrite. So the first equation, 2x minus 4y equals negative 7. And then distribute the 4 into the second equation. So 4 times 5, 20x. 4 times 1 plus 4y. Negative 1 times 4 is negative 4. So now we have opposite coefficients on one variable in both equations. In the first equation, y has negative 4. The second equation, y has positive 4. So now we can eliminate the y. This is the method of elimination. So we're going to eliminate it by adding the two equations together. Remember, equations are quantifiable. They represent a certain number of objects. So you can add, subtract, multiply, divide, and just kind of adhere to the equal sign. Everything on the left, add together, combine any like terms. Anything on the right, add together, combine any like terms. So 2x and 20x, 22x. Negative 4y and 4y cancel out, which is what we wanted to happen, so we're happy, that's good. Negative 7, negative 4 is negative 11. So then we solve for x, divide both sides by 22. X is negative 1/2. Oh my goodness, we got a fraction. Let's check to make sure what we did is okay. Multiply by 4. Okay. Add it together. Okay. Divided. Okay. So fractions are not necessarily wrong, but they make people freak out. So when you get it, just check to see what you did and make sure it's all correct. Then that extra value, you plug it into either equation for x and you solve for y. So let's plug it into the first equation, because multiplying by an even number versus multiplying by an odd. Kind of pick and choose our battles, okay? So 2 times negative 1/2 minus 4y equals negative 7. So simplify down, negative 1 minus 4y equals negative 7. Add the 1 over, negative 4y equals negative 7 plus 1, negative 6. And y equals negative 6 over negative 4. More commonly known as, that's a terrible 3, trying to hide my negative. Didn't mean to write that. Negative 6 over negative 4. 3/2. So you can put this together into an ordered pair. Negative 1/2 and 3/2. If you want to, just leave it as a list. X equals Y equals. Or you can make them an ordered pair. And then, ideally, you want to check your answer. So take your solution, plug it back in to make sure it works in both equations, and it yields true results. Okay? So when you're solving by elimination, there are kind of 3 moves you can do. Okay, kind of 3 things that you genuinely want to try. Remember, when you're starting a problem, you want to try something, see if it works. Can be something can be one of these 3 things, usually one of these 3 things. You can switch any equations so this is like make the first equation second, the second first. This isn't very useful with only 2 equations comprising a system. Later, when we look at 3 equations, 4 equations, 5, switching the order can be beneficial. Not so much right now. You can scale any equation. So that means multiply every term by a number, positive or negative. You scale it up or you scale it down. And then third, you can add or subtract any 2 equations. Now, me personally, I'd rather add than subtract. Subtracting can create problems with mental math more often than adding can. So if possible, you want to add, which is why I like to get opposite coefficients in the equations. So then you add and cancel them out. Versus getting the same equation or the same coefficient in both equations, then you subtract to cancel them out. I prefer adding. Now when you solve these, there are 3 cases for your solutions. You get exactly 1 solution. So that means that 2 lines are intersecting. Lines, nope. 1 letter later, lines. And that would mean their slopes are different. So they cross each other. So the slopes are not equal. You could have infinitely many solutions. So if we draw that, infinitely many means you have infinitely many x and y coordinates that satisfy both equations. So you have your first line, and then you have your second, right over the first. So that means these are the same lines. That would also mean their slopes are equal. We're going to draw the first situation also. Two different lines intersecting, different slopes. Then the third, if there's no solutions, so the lines don't intersect each other at all, well, that would mean the lines are parallel to each other. So graphical interpretation, they are parallel lines. And again, their slopes would be equal to each other. So there are a couple more examples in the section you want to look at. Kind of go through these steps, use the ones that are applicable, and then the answers you get should be in one of these outcomes. So look at those answers and check your answers with my completed notes online.